What's up, guys? Welcome to Sponge. I'm going to be explaining to you guys how you get a big bomb from small atoms. First, you have to understand what an atom is. Anything with mass is composed of atoms: solids, liquids, gases, or plasma. It is the smallest unit of ordinary matter that forms elements. To understand the nature of an atom, you have to understand its subatomic particles, which are your basic electrons, neutrons, and protons, as well as the nucleus, the center of the atom. And the key point is that to hold the nucleus together, it requires energy. Now, your lighter elements require less energy to bind the nucleus because there are fewer subatomic particles. But for example, in uranium-92, that has 92 protons, 92 electrons, and 146 neutrons, it requires great energy to bind the nucleus, which makes it a perfect candidate for an element to use in an atomic bomb. The key is to release that energy. There are two basic nuclear reactions that produce energy in physics: fusion and fission. With fusion, you're combining the nuclei of several atoms to create another element or to create energy. For example, 4 hydrogen atoms or nuclei combining to create helium, which is the exact process that the sun uses to produce energy and light for our planet. Fission is the splitting of nuclei, and this is the process that we're concerned with when it comes to creating the energy for an atomic bomb. Okay, so now we know that we're splitting atoms to release energy for the atomic bomb. But how does this work? So first you need the uranium-235 isotope, which is essentially just another form of uranium with a different weight but the same chemical properties. So this is how you create the fission of the U-235 isotope. So use a particle accelerator. You're going to shoot a neutron that's going to split the nuclei of the U-235. In that fissioning, your 2 new elements instantly form, an abundance of energy is released, and 3 new neutrons are formed as a result. Those 3 neutrons are expected to continue the chain reaction, fissioning more and more nuclei until eventually you have the end result: a massive explosion. This fission process is taking place inside of the atomic bomb. The material is lined with a mirror to keep the neutrons from escaping and to ensure the chain reaction. But to be able to control the timing of the chain reaction so that the bomb doesn't explode when you don't want it to. When the time comes for the bomb to be detonated, the 2 subcritical masses are slammed together by a traditional chemical explosion, such as another bomb. And when they combine, it creates critical mass, and then you have the fateful explosion. Thank you for watching Sponge, and remember, absorb more life.